So you've almost certainly spent a good amount of time solving equations. Let's start with a very basic equation. 4x plus 5 equals 2x plus 9. You probably remember the overall philosophy here is to get everything with an x on one side and everything without an x on the other side. Let's go ahead and do that. Let's go ahead and subtract 2x from both sides. And that gives us 2x plus 5 equals 9. And now we'll subtract 5 from both sides. And so we end up with 2x, the 5's cancel out. And we just end up with 4. 2x equals 4. We can divide both sides by 2. And we end up with x equals 2. Whether we put a box around it or not is immaterial. The point is, this is a solution to this original equation, which means if we plug this number in, the left side and the right side should agree. Let's just go ahead and double check. So the left side, if we plug in x equals 2, we'll put a 2 in here. So 4 times 2 plus 5, and that equals 8 plus 5, which is 13. And the right side, we end up with 2 times 2 plus 9, that's 4 plus 9. Again, that's 13. Notice that the left side equals the right side. And that's what makes x equals 2 a solution to this. If I plug any other number in, this is the only solution. So if I plug any other number in, the left side and the right side are not going to equal. If I plug in x equals 3 or x equals 5 or x equals -2, the left side and the right side will give you something different. The only thing which makes them the same is x equals 2. An equation can have one or more or no possible solutions. Let's just take a look at another equation, also very simple. How about I have something like 2x plus 3 equals 2x plus, I don't know, 5. So we will, let me go ahead and subtract 3 from both sides. So we end up with 2x equals 2x plus 2. I can subtract the 2x from both sides. And that gives me 0 on this side. And the 2x's cancel out here. I have 2. And you might be looking at that, what you end up with here is 0 equals 2 and wonder what that means. Well, does 0 equal 2? No, it doesn't. It doesn't matter what x is, 0 doesn't equal 2. There is no way, if x equals 5, 0 still doesn't equal 2. If x equals -2, 0 doesn't equal 2. There is nothing I can plug in for x, which will make the left side equal to the right side. And if you look back up here, that becomes obvious that the right side is always 2 bigger than the left side, no matter what you put in for x. So the original equation has no solutions. The original equation has no solutions at all. Let's just take a look at another variation. 2x plus 3 equals 2x plus 3. If I subtract 2x from x plus 3 from both sides, I end up with 0 equals 0. Well, is that true? Yeah, 0 equals 0. I guarantee 0 equals 0. And it doesn't matter what x is. If x is 5, 0 equals 0. If x is 8, 0 equals 0. So every number is a solution to this. Every number you can plug in for x will make the left side equal to the right side. That's fairly obvious here. And so this has all solutions. So we can say all real numbers are solutions. Or we can write all real numbers like this. We saw that in the last video. Or we can write it -infinity to infinity. Every real number is a solution. Or you can graph it on the number line if you want. You don't have to do all of these things. Any one of these things would be fine. But we can graph it on the number line. Let's take everything between -infinity and infinity and shade it in. So hopefully these sort of first order, these kind of linear equations, whether they have one solution or infinitely many or none at all, that these are fairly straightforward. You also almost certainly at some point have studied quadratic equations, equations with an x squared term in them. And at some point, you almost certainly did what was called factoring. So let me give you an equation which is already factored. So let's say I have something like this. X plus 1 times x minus 3 equals 0. When you're using factoring, now this is already factored. This is already the product of two things that are in parentheses. When you're solving an equation using factoring, it's very important that what's on one side of the equation is a 0. And the reason for that is that it's very easy to decide when two or more things multiply to give you 0. If two or more things multiply to give you 0, one of them has to be 0. So the very next line, since this times this is 0, one of these two things has to be 0. Either x plus 1 equals 0 or x minus 3 equals 0. If x plus 1 equals 0, we can get x by itself. So we'll subtract 1 from both sides. So x equals -1. And if x minus 3 equals 0, we can add 3 to both sides. So x equals 3. That's why the signs here always flip when you actually solve these things. It's just because you're moving this onto the other side. That's the reason. And we'll put the word or there. This equation has two solutions, and there they are. Let's take a look at something where we have to do the factoring ourselves. Let's say I have something like x squared minus 7x plus 12 equals 0. X squared minus 7x plus 12 equals 0. If I could write it in factored form, then I could do the same thing I just did here. So let's go ahead and see if we can do that. So I will put two parentheses there. I'll put my equals 0, and I'm going to put an x here and an x here. X times x comes out as x squared. So we're looking for two numbers we can put here and here, just like we had two numbers here and here. Here we had +1 and a -3. We're looking for two numbers we can put here and here that multiply to give you +12 and add to give you -7. So if they multiply to give you +12, they either both have to be positive or they both have to be negative. Since they add to -7, they both have to be negative. You can't add two positive numbers and end up with a negative number. So we're looking for two negative numbers that multiply to give you +12 and add to give you -7. We don't have to think too long before we realize it's it's a -3 and a -4. -3 plus -4 give you -7, and -3 times -4, the minus signs cancel out. That gives you +12. And hopefully that kind of factoring is something that you've done before. I'm hoping this is review. If it's not, please contact me and I'll run through it with you. I will help you work on that factoring skill. But once we have it written out like this, then just like before, we have the product of two things that gives us 0. One of them has to be 0. So either x minus 3 is 0 or x minus 4 is 0. One of those two things has to be true. The product of these two numbers gives you 0. One of them has to be 0. And again, we can add 3 to both sides here. If I add 3 to both sides, if I add 3 onto the left side, I end up with x. If I add 3 to the right side, I end up with 3. And if I add 4 to both sides here, I get x equals 4. So either x equals 3 or x equals 4. That's the whole point of factoring. That you want to get a 0 on one side, and so the product of two things gives you that. You know one of the things has to be 0. So let's take a look at a slight variation on this. Let's say I give you something like x squared plus 12 equals 7x. Now, for one thing, with this on the blackboard over here, you realize that this is basically exactly the same question. It's exactly the same question, because if I bring the 7x over onto this side, if I subtract 7x from both sides, I will have exactly what I had over here. And if you're looking at something like this and thinking, I might have to factor that thing, you're going to want a 0 on one side of the equation. So you definitely want that 0 over there. So it should be a natural inclination when you see something like this You want to bring this on the other side. We'll subtract 7x from both sides. And I'm used to putting my x squared term first, and then the term with the x in next, and then the constant term. And when I subtract 7x from both sides, I end up with a 0 on this side. And then it's exactly the same problem I had over here with exactly the same answer. If I had written it like this, x squared, let's see, minus 7x equals negative 12. Again, it's exactly the same problem I have over there. And you're looking at something like this and you're going, I think I might want to use factoring for that. I had better bring everything over onto one side of the equation. I will add 12 to both sides. X squared minus 7x, add 12 to both sides, so plus 12. And it leaves me with the 0 that I want on the other side. Anytime you use factoring to solve an equation, doesn't matter how complicated the equation is, you definitely want a 0 on one side of the equation, which is exactly what we did here and here. Let's say we take a look at something like this. X squared equals 1. You might be able to eyeball the solution to that. Hopefully, if you do, you will spot the fact that there are two solutions rather than just one. I mean, the first one that probably pops into your head is that that works if x equals 1. When you square 1, you get 1. Let's go ahead and try to use the same philosophy that we used over here. We might want to factor. So we will bring everything onto one side of the equation. So I'll subtract 1 from both sides, leaving me with an x squared minus 1 on the left and a 0 on the right. As soon as we see that 0 on the right, we know we're on the right track. And then this thing factors. Again, I hope this is review. If it's not, let me know. But x squared minus 1, that's a factoring form called difference of squares. We can factor this as x, and then x minus 1 times x plus 1. And if you multiply this together, hopefully you realize that you will get that. I mean, we can multiply this together. If we FOIL this all together, we see that we get x times x is x squared. Then there's a plus x and a minus x. They cancel out. And then a minus 1, which is exactly what we had up here. So this and this are the same. And once we have this, it should be pretty straightforward that x minus 1 is 0 or x plus 1 is 0. So here we have x equals 1 or x equals negative 1. Again, if there are any steps here that are not making sense to you, please let me know and I'll run through them with you or make another video to hopefully explain them in more depth.